Come now to the third of the tricky simultaneous equations, and here they are. Y plus z plus yz equals 3, z plus x plus zx equals minus 1, and x plus y plus xy equals minus 1. So I'll tell you how I proceeded to do this. First subtracted 3 from 2, and that gives me z plus zx minus y minus xy equals 0. And then that factorizes by collecting the terms as we've done here. And then the factorization is obvious. It gives us z minus y times 1 plus x is 0. So we either have z equal to y, or x equal to minus 1, or maybe both. All right, now from these, starting from here, I just want to cut a long story short. I was easily obtained some solutions, including the following: minus 1, minus 3, minus 3, that one, and minus 1, 1, 1, that one. And then the question arose in my head as to whether there were any further solutions to be found. And the answer, as I've written down here, was very surprising. So I considered a trial solution, for example, a let z equal 2. No reason for choosing 2, it's just that it's a nice small number. Okay, substituting that into equation 1, right over here, we get y plus 2y is 3, which leads to 3y equals 1, and y equal to 1/3. Now I substituted these two values, the z into equation 2 and the y into equation 3, and in both instances we got the answer x equals minus 1. So we've got another solution here, minus 1, 1/3, and 2. So we're down to there. So now the obvious thing to do was to consider z equal to some random number, which I've called a. And then repeating the process, which I've already gone through. In equation 1, y plus ay is 3. So factorizing a little bit, we get y into 1 plus a equals 3 minus a. And then y equals 3 minus a over 1 plus a. Okay, so what we've got here is z equal to a and y equal to 3 minus a over 1 plus a. Now substituting z equals a into equation 2, or y equals 3 minus a into 1 plus a into equation 3, both then give x equal to minus 1. So it seems that there are infinitely many solutions for this equation, okay? And there'll be, this particular solution set will be x equals minus 1, y equals 3 minus a over 1 plus a, and z equals a. And you have to stipulate that a is not equal to minus 1, otherwise the y term would just be infinite. I've remarked here that this was most unexpected, and I've not found any alternative solutions. So I'd be very much obliged to any of you who happen to listen to this little episode if they can throw any further light on this particular problem. I have to admit that getting this solution here was not any stroke of genius on my part, okay? It was just trying to dip my toe in the water to see what came up. So I'll end on that particular note. Thank you for listening.